Are we live?
Not yet, no.
I think now we should be there, no?
Yeah, it's live now.
Okay, cool. We're live.
Are we?
Okay, okay. Hi guys, I'm Neeraja. I'm the secretary of IITG.ai. Apologies for the confusion. I think we're a bit late, but anyways, let's get started now. Firstly, welcome to the orientation. And so today we'll just be, taking you through like what AI is, maybe a quick introduction, and then we'll just go through some applications of AI and interesting stuff about it, and then we will start talking about the club. I think one question was, is this a club or a part of a club? So IITG.ai, it is a club in itself. So hopefully we can address more of your questions later on. All right. Okay. Let's begin. Abhilash, can you go to the next slide? Yeah. So around 1950, the previous one. Yeah. Yeah. So there was this. I don't know if you guys are familiar, but Alan Turing is a very well-known mathematician slash computer scientist. So around the year 1950, he started to think whether machines can think, or at least as intelligently as humans. So this is where the whole question of AI, and AI being the concept of whether human intelligence can be simulated in machines started. So AI, simply put, is this branch of computer science that tries to figure out how we can make machines think like humans, or perform to the capability of human intelligence. Can you go to the next slide? Yeah. So AI in itself is consisting of various subfields. So there is ML, there is that is machine learning. Then there is natural language processing. There is computer vision. There is robotics, and variety of subfields. Under this domain of AI. So you and these subfields also, they also have like they are also branched into many other fields. For example, you can see that machine learning, deep learning is a subset of machine learning. So usually in the starting, you guys might be confused because, machine learning, deep learning, artificial intelligence, all of them are, it may seem like they are used interchangeably, but ML is a subset of AI, and DL is a subset of that. And maybe once you guys start going through courses and all of that, you will be able to figure out the exact difference between all of these and all of that. While this was just a fancy introduction of what AI is and what it can do, the fundamentals of AI, or at least the basics on which it is built, is just simple mathematics. And yeah, so that's it. Animesh is going to be taking over now.
Yeah, yeah. Thank you, Nija. So, welcome everyone. So Nija so far has elaborated out what, in a very brief sense, is AI. However, I think we all know here that one cannot, start doing anything or start studying anything if the person has no idea what this field of study is made for and what problems it tries to solve. And I hope that everyone understands here what I mean by that, because you might have felt it. For example, through your JE, some topics just didn't, doesn't seem to have any goal in certain directions, but you did it for, just getting marks. In that sense, at least. So that is why I think it is very essential and essential to present why we should actually pursue AI and related machine learning goals in an attempt to solve some of the biggest questions that we have as of our existence. So, going briefly, well, one of the central goals of mankind is to answer the basic questions of our existence. Like, for example, why is there something rather than anything? or why is there why nature seems to have certain patterns in its existence, and certain times it does not seem to have any pattern. These are some really big questions which, by their very definition, does not have any trivial answer. Uh, and of course, you might, as soon as you hear this, it will almost certainly will be you will ring this bell that these are very difficult questions in the sense that they don't have any predefinite answer. It's not like solving an algebraic equation. Its answer can be a lot of times subjective and very difficult to even begin to answer. Now, why this difficulty arises in answering bigger questions of our existence is actually quite philosophical. This happens for a variety of reasons. First of them, some are local, some are global, some are very global. What I mean by some local reasons is that some people just don't want to pursue these questions, or the answer of these questions certain times don't seem to have any fruitful directions. These are some local reasons, but some global reasons are also there. One of the global reasons for why there are certain difficult questions, as such we have today, is due to just nature. Actually, there's not much to think about it. Like the nature has certain constraints in which you cannot actually solve some of these bigger questions. One of these bigger question is bigger questions or bigger results, or very profound results, I should say, is Gödel's incompleteness theorems. Kurt Gödel was a very famous logician and mathematician, and in 1931 uh, he discovered one of the very founding pillars of mathematical logic as we know it today, which is called in Gödel's incompleteness theorems. These theorems actually make sure that there is no algebraic a model or axiomatic system of model, or a theory, I should say, that there is no theory which can completely determine all the truths about natural numbers. So I hope that you can understand how profound its effect is, that you cannot ever make any theory which contains every result of using those, which that theory you can derive all the results about natural numbers. And this have very profound impact on not just philosophy but on mathematics too. Because before this theorem came out, a lot of great mathematicians like Hilbert and others had this program that they want to formalize a whole mathematics in an axiomatic system in which there are certain few 10 or 15 axioms on which whole of mathematics, and thus whole of physics, and thus whole of philosophy, and thus whole of medicine, and every other uh, topic which uses mathematics will be built upon. But Gödel's incompleteness theorems tells you that this is just not possible. So this is one of the profound impacts of asking bigger questions. Another impact is on undecidability. I hope some of you might know about this Turing machines, and in general this word undecidability, it's quite self-explanatory in the sense that it just means that there are certain kind of problems whose answer can be yes or no, but you cannot determine whether its answer will be yes or no in finite amount of time. And of course, so this is like a meta problem now, a problem of problems, in the sense that if I want to ask whether certain problem can be decided in finite amount of time, it's in itself is a problem. You see, because it takes infinite amount of time if you use inefficient algorithms or something like that. In a broad sense, these are the problems we face when we ask some really big questions. Coming back a bit, we have that the problem with these set of problems are that these results, some of the basic results that I hope some of you might have done in, for example, just have done MA 101. If you would have paid attention, then you would have noticed that there are certain theorems or propositions which we prove, which requires a very intricate step of logical connections. After making those connections, we finally get from what we know in the question and to what we desire to prove. So these logical steps, as we are humans, we are not actually made for making these logical connections, as you might have noticed too also. That it requires a lot of training and a lot of practice to do so. And even after that, there are famous stories. People keep working on certain research topics which they think that certain people 20 years back proved correctly, but it turns out recently that the proofs were not correct. And these are some really abstract mathematical theories in which some people actually got prizes for proving wrong stuff. So you see, we humans, as humans, we are not actually logical beings. Not in the sense of like talking logic all the time, but applying logic for a very long, intricate chain of steps. We are not just built for it. So now the thing is, there are certain patterns in logic. Can you move to the next slide? Yeah. So apart from this, we also have like major. If you remove all these mathematical theories and everything of physical theories, we still, if you don't look at whole nature from mathematical perspective, we still have a lot of problems. One of them is that there are patterns everywhere. Patterns in nature, patterns in sunflowers, arrangement of seeds, and patterns in honeycombs, and so on. And some of these patterns are, of course, mathematical, and some are not. And also, some of these patterns are easy to solve or easy to see. Can you move to the next slide? Yeah. For example, like Mandelbrot set, we all know it's made from a very simple equation. This iteration for all those numbers and all those complex numbers for which this iteration converges, that is your Mandelbrot set. But the problem with this is that it is a very simple equation and it uncovers a lot of stuff. But and in fact, if you notice very closely to this, is that in a sense that the sentence that is written on the right hand side of the implication, you can see that it is in some sense a compression of all the information that is on the left hand side. So in this sense, mathematics is like a compressor of information. But yes, these are some of the patterns in nature that are very easy to detect. And if you go to the next slide, these are some of the patterns in nature which are, well, not even come close to being defined correctly. So this is the Navier-Stokes equation. And as you can see, it's a very big equation and a big mess, which defines the flow of fluid in a medium. And its solution is actually one of the 7 Millennium Prize problems. So if you solve this equation, and the whole problem is like this: if you can prove or disprove that it's Navier-Stokes equation solution, there is a solution of Navier-Stokes equation which defines, which is smooth and which is defined everywhere, then you can indeed get a $1 million in cash prize and an eternal fame in book of mathematics. But of course, nobody has even come close to it, solving it in the sense. But in the process of solving this, we have built upon a lot of theories and a lot of tools which are used in a lot of different areas. So these patterns, which this is the turbulent flow, is something that of course we all see when we fly in an airplane and even walk in the air. But it's inherently very difficult problem to solve. Now, so we have in a sense, very simple problems to solve, like Mandelbrot set. We can easily determine what function makes them, and then we have Navier-Stokes equation, which is not that difficult to explain. The thing is, the problem of problems in itself, as we will see in the next slide, the problem of problems in itself is a very big problem. The question of classification of problems in it, whether there are certain problems which we can solve, are in itself very difficult. The classification of all those problems which we can verify are correct in itself becomes a difficult problem. So what I mean by this is that the solution to a problem is, if the question of P is equal to NP is that if the solution to a problem is easy to check for correctness, must the problem be easy to solve too? So that is the question here. So the P and NPs are set of problems themselves. P is the set of problems which you can solve in finite amount of time very quickly, And NP is the problem of set of all those problems which we can verify are correct in finite amount of time. Is all of those, both of the sets same or not same, is in itself one of the seven uh, Millennium Prize problems. So you can see how much complicated these bigger questions get very easily, and people are not even close to answering these questions. So the computers, however, now this is where we are now, after building upon motivation, comes towards AI and how it can help. So computers, as we know, are extremely fast in performing a very basic set of operations. Uh, Multiplication, division, addition, subtraction, they're pretty fast at it. Billions of operations per second, we all know that. But as we also know that they are not able to reason effectively using these operations, at least so far. Now, this is where AI comes in and tries to solve this problem by taking the best of the both worlds. If you can move to the next slide, uh, what AI does, at least hopes to does, is to combine the reasoning power of humans, especially our brain, which reasons, and combine with them the computing power of a computer. Because we can reason very well, but the thing is, we cannot do it fast enough. We cannot divide 2 trillion numbers in a second, or 1 billion integers in 1 second. But a computer can. But a computer cannot reason just like we do. What if we combine both of these power? Then we can have a much better reasoning ability in a machine, and of course, the inherent computing power of computers are already quite high. So this is the hope of AI, that we could use such hybrid combination of reasoning and computing power to solve some of the biggest problems of mankind. So this is the motivation, because as we saw in the previous slides, there are certain problems which are just not difficult to solve, just impossible to solve, and that is in itself a very important or profound, for the lack of better words. They are profound problems, and people are still working towards them. And AI is also catching up to solve some of these problems. In fact, recently there has been a paper in which an AI model actually infers equations for dark matter and its inflation in the universe. So you can see that some of these models are now really getting up to that level where they can contribute to these problems for which these models were made for. I mean, apart from these, there are very little use of them, if you will notice, because if you, the problem of these questions, as we mentioned in the previous slides, are quite important. So, how, for example, how nowadays, how does these models actually learn these stuff, like, for example, dark matter equations, by observing the inflation in the universe? How does an AI can do that? Towards that, we now go into somewhat technical stuff. So currently, most of the AI models are based upon compressing the knowledge, in quotation marks, knowledge, and its representation, again in quotation marks, in certain statistical models. So they try to take the information that they are seeing and compress it into the in certain sense placeholders that they have in themselves. So if you might have done, some of you might have done linear regression, and you must have done in PH 101. You might have seen that there's a weight and bias terms which compresses in certain sense the information of all the inputs that you might have provided it with. And this compression, how do you compress this? These are, now we are getting much technical into how these happens, like neural networks and all. So, so, yeah, and most of these are done in the context of statistics. So in statistics, you have multiple, not just one input. You have a sequence of inputs, or a collection of inputs upon which you want to train your model. Now, what it means to train your model is to fit your parameters of the model to represent the knowledge that is contained in that set of inputs or set of data. So that is what happens. And again, how can you compress these information? You can compress them in there's one way to compress them, that is an affine transformation. That is, you guys have already learned about it in linear models. That is linear regression, y is equal to wx plus b. So you take the input x and you compress its information in the weights w. So that's how this happens. And I think that was at least I hope that you understood that how these models actually um, why AI is at least important in these big scheme of questions and problems that we have as a species. So yeah, thank you. Uh,
Yeah, so that was the basic introduction. And so now Akshit and Varun will be taking over.
Hello everyone. So now you will be shown a couple of pictures and you have to tell who are they. They might be famous people, they might be prominent figures. You have to tell us who do you identify. So can you change the slide? Yeah, I think you can see the picture. Do try to tell who they are. So you can go to next picture. I think you can go. Yeah, try this one. So I think I've given enough time. So you can go to next slide. So let's check the answers. I think you might be surprised. Let's see. Next slide. Yes, the answer is these people do not exist. That's the answer. These images are actually generated by AI. So these are actually made by AI models called GANs actually. They are specialized in generation of images. So these people are generated from AI. They don't really exist. So below is a website which you can visit. This contains all the images that are generated by AI. So you can check the potential of the AI. So you can go to next slide. So as you saw that AI can generate images, but that's not all. AI can do a lot many cool things that you cannot even imagine. So let's check some of those out. Next slide. So can you play the video? Just starting part. Just 10 seconds or more. The start of speech. Can you hear the voice? I think you cannot hear. Can you tell in the chat if you can hear the voice? Okay. So basically, can you try the YouTube link? There is a YouTube link right. Okay. Okay, there might be a problem. So basically what this AI application is that it can take the video, initially the video was in English, the professor spoke in English, and then by application of AI, we can convert his complete speech in say Hindi. So after conversion, you can hear the exact same stuff that was presented in English in Hindi. So as you might know, the applications of this are enormous. So can I go to the next slide? Yeah, so one more question. Suggest an interesting application of the above technology that you just saw. It's basically the English speech can be completely and smoothly transitioned and converted to Hindi speech. So what do you think you can do? Yes, we have got some interesting answers. Yes, virtual translators and real-time translation are really good ideas. So, so can you go to the next slide? So one more application. There are many applications. So one of that is games. So AI, you can teach it. So basically, it's a model. You can teach it to do anything. One of the thing is playing games that we all do. So this game is AlphaGo. It's a game. There are world competitions in that. So DeepMind is an organization. It's basically a research laboratory which creates interesting AI applications. So it made AlphaGo. AlphaGo is an AI model which can play basically AlphaGo. AlphaGo is a game, and so, so this AI beat one of the top world champions in that game. So you can check out that there is an interesting video. It's a full documentary of its full making and how it beat its full story. You can just search it, DeepMind's AlphaGo. You'll get it. It's pretty interesting. I suggest you to watch it. So that's an interesting application. So next slide. You can take over.
Yeah, okay. Now I will show you an application of AI playing a game called Air Striker Genesis. Basically, the game is shown in the video here. Now we will train the computer to play this game, and we will see at the end of this presentation how much the computer has learned how to play this game. Basically, we are given a game to the computer, and computer just know the screen. There are some fighter jets, and we need to play it. And it has only two controllers, left and right. And by the end of the video, like after like 1 hour or something, the computer will learn how to play this game. And by the end of the presentation, we will show how well the computer is performing. Someone continue.
Yeah, all right. So, can you go back to the slide? Yeah. So, hey guys, I'm Akshat Sinha. I'm a sophomore, and I'm the guy who was interacting to you in the YouTube live chat. So basically, I'm the one who decides who gets the goodies and who gets not. So what I'm doing here is like everyone is not interested in like theoretical maths, obviously. So what gets other people interested in AI and stuff is like the cool things, the things you can see, do something which you can also do. Like for example, this is a application of image segmentation. What it basically an object classification. So what basically is being done here is, so we give an image to the AI, and it's looking through the image to find what all objects are present in this image. Like you see there's a box around the car, you see there's a box around the various people, and so it does multiple steps for us. It does multiple steps for us all through itself. It finds out what are the images of importance in the image, and then it classifies those objects too. So this was one thing. Can I have the next slide, please? Yeah, so here's what we have is style transfer. So style transfer is basically, you have two entities, not in necessarily object, not necessarily images. You can have any two entities. You can extract the style from one of them, and you can impose it on the other of one of them to get a whole new entity. Like for example, here are the paintings. So we see a Steve Jobs image and a floral painting, and then we see the accumulation of two. You can do it with pretty much anything. You can make yourself sound like Stephen Hawking using this style transfer. You can take a picture of yourself and you can turn it into a Pablo Picasso painting, for example. So the possibilities are endless in style transfer too. And and yeah, so that's pretty much it for style transfer. Can I have the next slide, please? Yeah, application in medicine. And this one might not seem very cool to you, but it's a big region of interest in the AI community, and it's rapidly developing. So if you do any AI ML courses in the future, you might start off with Andrew NG machine learning course, and one of the first things you do in there is, you classify a tumor as benign or harmful based on its size, based on its height, based on its diameter, etc. And so AI has a lot of applications in medicine too. A recent development is, you guys are fresh off from JE, so you might have heard of amino acids, and like how proteins are basically chains of amino acids. So you know how a protein structure will look, but given a protein, given a sequence of amino acids which is a protein, you cannot predict its structure without seeing the protein. Or This used to be the case until recently, when a new, I forgot the startup or something, which came up with a deep learning model which could predict the structure of the protein, given only the sequence of amino acids present in the protein. So this was a very big development. This was a very big development in the application of AI in medicines, and everyone is constantly working towards it. And so this is a very good implementation of AI as well. Next slide, please. Yeah, deepfakes. Deepfakes are. Uh, I will let you see this video. Sorry, there's no audio. So basically, what's happening here is, there's this girl who's uh, made to sound just like Donald Trump, using AI models. This is also a kind of implementation of style transfer, where you take the style of Donald Trump, if he has any, I guess, and you impose it on this video of a girl speaking, and there you have it. This girl is acting, sounding just like Donald Trump's, all through the work of an AI. And so this is also a fun implementation of AI, and this isn't very difficult. Like, lots of people do it all throughout the world and post their findings on the internet. So this is also a fun implementation of the AI and stuff. Next slide, please. Yeah. So are you guys not able to hear me? Like, I saw comment on the YouTube live chat saying unmute the presenter. Ah, you were talking about Donald Trump. Okay. So moving. Uh, can someone confirm if I am audible, Nija Didi?
Yes, yes, you're audible.
Yeah. Okay. So moving on. So this one is a this one is honestly mind blowing for me because you are teaching AI to write just like an human. You can write books, novels, stories, code, even code. Like a lot of us are spending time learning how to code, but it might be the case that in future AI does all the coding. You just have to give instructions to AI like what to do and how to do it. And so yeah, this one is also very cool because it takes a lot of effort for the human mind to learn how to code, and if we can teach an AI to do the same, it would be a groundbreaking invention for us. Can we move on to the next slide, please? Uh, so again, we have a question like find out which of the following is written by a human. Like we tricked you last time, we won't trick you this time. So there are three instances of something a story being written, and you have to find out which of them is written by a human. And I would answer another previous query. Yes, we are giving out goodies. So can I have the next slide, please? So here are the three excerpts of a story or something. I hope you can read it. And just to start you off, I'll read the first paragraph of each one of them. So A, in order to get something done, maybe we need to think less. Seems counterintuitive, but I believe sometimes our thoughts can get in the way of creative process. B, a winter's day when beams of sun are few and skies are grey with cloud intemperate, whatever that means. And C, when the boy came back, the old man was asleep in the chair and the sun was down. Yeah, okay, so there are three of them, and some of them are written by AI, some of them are written by human. And so you have to figure out which of them are being written by AI and which of them are being written by human. uh, you can figure this out and write in the chats. MC by AI. Okay, so I'm getting some answers here. CNPC. Okay, so yeah, can I have the next slide, please? Yeah, so here's the answer. C is an excerpt from The Old Man and the Sea, a classic by Hemingway. And A and B are generated by GPT-3, NLP model, which takes the style from Hemingway and generates, or Hemingway or some other writer, and generates a story or something. Yeah. So we'll go through the chats and we'll find out who gave the right answer afterwards. Can I have the next slide, please? Yeah. Okay. So another question time, and in this one, we are back to maths. Uh, Apart from P versus NP, there are some other famous problems also. So this one is the classic Monty Hall problem. Suppose you're on a game show and you're given the choice of three doors. Behind one door is a car, behind the others goats. You pick a door. You have to find out basically which door conceals the car, and if you do it, you get the car or something. So you pick a door, let's say number one, and the host, who knows what's behind the doors, opens another door, say number three, and which has a goat. He then says to you, do you want to pick door number two? Which would you like to switch and why? So give the answer. So I'm getting some answers. So you might want to explain why. Yeah, okay. So I got plenty of answers, and many of you are correct. Can we have go to the next slide, please? Yeah. So the probabilities that your initial choice Yeah, so you can calculate it out. It's not very difficult. So I'll give you the basic intuition, which is before picking anything, if you are given a choice of picking one door or picking other two doors, and the probability of finding car behind the one door is 1/3, and probability of finding car behind the other two doors is 2/3. So in this case, the other two doors are clubbed, and opening one of the other two doors simply does not change the probability of car being behind those two doors. So yes, picking the other switching the door would increase your probability of finding the car. And yeah, so this was a Montreal problem. I let can I get the next slide, please? Yeah, I let Nirja Didi take on from here.
Hello. So basically, that was an introduction about AI. In the starting, we had a bit of at least about the math, and after that, I think you guys got to see some cool applications, and hopefully, you get a basic idea of what AI is and what it can do. So now we will be talking about IITG.ai, which is a club, and Abhilash, next slide. Yeah. So we are a group of students, rather dedicated group of students, with an aim to accelerate collaboration amongst the students in AI research and development. So we do focus on both, the research aspect of it as well, and the implementation and the application aspect of it as well. So I think that's why, some of you were asking, like, is this a math club or something like that? So the answer is there is a place for everyone. There is a place for people who are interested in just the mathematics of it or just the research aspect of it. And there is also a place for, people who are more interested in the applications of it, or, people who want to use AI to do some cool, simple projects. And there is also a place for people who are interested in both. And one thing you must know is, especially in this field, since it is very vast and currently, there are like a lot of developments that are going on, that research and the development aspect, they both go hand in hand. So, to improve these AI, one second, Abhilash, can you just mute yourself? So to make, applications that perform really well, you need the research to also improve. And once you have better research or better developments in research, your applications can perform better. So this is, they are interlinked, and the development in one will, help out with improving the other. So the important point is, in IITG.ai, there is a place for, everyone, irrespective of if you're only interested in research or only interested in the applications, or if you're interested in both of these. So yeah, next slide. So yeah, as I said earlier, in this field at least, every day there are like at least, thousands of new papers that are there on different topics. So as an individual, it is very difficult for someone to, keep up with the state of the art of any field for that matter. In fact, as in the starting, I might have shown you, there are different fields in AI. And usually you will be surprised to know that, people end up working only in one of these fields. And even, either in the subfield of machine learning or computer vision or natural language processing. And even in this field, like, people throughout their lives, they might end up working only in a smaller problem, because that is how vast this is. So, keeping up with all of this by oneself is very difficult. So that is where it is important for to have mentors and peers. So that, these mentors and peers where you can learn and discuss from. And IITG.ai is the perfect environment for this. So we have people, with experience in different areas, different subfields, different domains. So there are, some of us who just like to focus on the research aspect. There are people who work on both. There are people who, just like to work on the applications. And there are also people who work in the different subdomains that, we guys showed you earlier. And also, as an undergraduate, since, we are a club that also focuses on research, it is very difficult for us to just work on our own, because currently we do not have that experience to maybe just dive into research without any help, any external help. Which is why IITG.ai, we in IITG.ai we collaborate with different startups, different professors, alumni, and mentors across the world. And luckily, since this is a software club, we are able to do so easily. And also, you guys might have seen the video of where Steve Jobs is speaking in English, and it gets translated to Hindi. I think the you might not have heard the sound, but that video, it is a work which is being done by a startup, and some of us are that video is not done by us, but we are helping with that startup. And yeah, so that's how it is. Next slide. Yeah, so this is the team. The people here are the third year, right? So we'll just go one by one and introduce ourselves, whoever is here with us right now. So I'm Neeraja, I'm the secretary. And Animesh, can you go on?
Yeah, I'm Animesh Rinans. I'm the ML head. I focus majorly on the the papers or the work which is done uh, uh, in the span of ML, which generalizes most of the CV, NLP, and the theory based upon it. Yashwant.
Yeah, hello, I am Yashwant. I specialize in computer vision, like how the AI can process images, detect like from image segmentation and detecting things in image and doing everything that AI can do in images. That's called as computer vision. I specialize in that field. Yeah.
Hello, I'm Abhilash. I'm the NLP head. Basically, NLP is the field of artificial intelligence that gives machines the ability to read, understand, and derive meaning from the human languages. Like from the previous examples, we shown the Steve Jobs speaking in English is translated to Hindi, or the GPT-3 is generating like new essays, like the style transferred essays. Those things will come under NLP. Basically, I work on those things. Divya Kanti.
Divyakanti is actually not here. So, Animesh Tiwari, can you just introduce yourself?
Uh, my name is Animesh Tiwari. So, my interests are basically in machine learning and Bayesian methods, and as well as the computer vision related research related to AI. And I like to I like to work on the vision related projects as well, which we uh, which we try to like improve upon the uh, uh, pre-established research work and as well as the Bayesian methods. Yeah, I like to hear from the others.
Okay, Abhilash, can you go to the next slide? Yeah. So, as I did mention earlier, as an undergraduate, it is difficult for us to, do a lot of stuff on our own, especially when it comes to research. So, this is where, we do have like a strong support system of mentors. So, including these are some of our co-founders. And then we have Aditya Bhaiya, he was the secretary last year. And there are also many other people who are our mentors. We were not able to compress them in this one slide, but yeah, so the aim is that we have like a good network with them, and then they help us with they collaborate with us on some projects, or that's how it works. Next slide. Yeah. So now we will go ahead with what we do in the club at IITG.ai. Next. Yeah. So some of you were asking about our projects. So here is some cool stuff that we have worked on in the past. Yeah. Next. Yeah. Yashwant. Yashwant
Yeah.
will take.
Can you start from 30 seconds? Yeah, as you can see in the image, the source A is we can choose gender, age, hair, like any of the future from these images and combine with like the remaining images. So as you can see, as the I think Neeraja showed some images that were generated by AI. So that was my part. Like we can not the faces, anything, any image. We can take the future of another image and add into it. So these are the example. I think you got to know by now like how the style of other images are adding to this images. Yeah, that's it.
Yeah. Just pause at yeah. Just pause. Yeah, just pause it here. Yeah. So this is basically one of the basic computer vision projects related to AI. So as we have been through this presentation, and we had a very good presentation by Animesh Renanj, that he said that we basically try to mimic the human brain, uh, we teach the computer to mimic the human brain, and like to automate the things which can be uh, really difficult for us as well. So what we basically do here is that, say if I am watching a game of cricket, I'm sitting on my chair, I'm watching a game of cricket, and I see that a player is playing different kinds of shot, right? It can be a cover drive, it can be a straight drive, it can be a pull shot. So why not to automate this action prediction? Like why not to teach a computer to predict the type of shots a batsman is playing in a live session? So this is the initial work of the project, which is currently going on in our club. And this in this initial work, what we have done is basically to segment the player from the background. You can see that the system which we have initially trained on has been able to segment basically the player from the background. So what we do in the segmentation is that we separately classify a type, like an object, from the background, and from a temporal frame of these sequences we try to predict the action in a given time step, like for a particular time. And like we feed that particular feature set into a model, and what that model does is that it tries to mimic and classify what type of action a particular video frame is going through. So you can play this video a bit. Yeah, so you can see how well it classifies a person frame by frame. Like a video is consisted of multiple frames, and what it does is that for each frame it classifies a person, and we can initially live track the ball. And what we can improve on it is that we can try to classify upon these segmented frames in a temporal time frame. Yeah.
So this is basically animal AI is a environment where the computer will control the animal's brain so that it can solve simple common sense reasoning tasks like finding food when the lights are dim and when there are obstacles were there. We can see our blue one is an animal and it is trying to reach the gold color food. There are different objects and obstacles so that it is difficult to find the food. We need to, like, the computer will learn how to find the food by searching through the environment and jumping. Like, it will learn how to jump, how to turn, how to, like, which direction it's done, all those things. It is learned by the AI in this project.
Yeah. Vilash, can you play the video?
Yeah, it's
Okay,
already
okay.
playing.
Yeah, so this project is called Face to Text. So basically, what it does is, it tries to describe a person's facial features and their expressions. So here, I think in red, I'm not sure if it's visible to you guys, but yeah, it says, a young man with dark hair and small eyes. His nose is small, his lips are thin. He's smiling, and his upper teeth are visible. So yeah, and now when he changes his expression, it says he looks serious. So yeah, so what this does is, you can feed in your an image of your face, and this tries to, describe your face based on your facial features, and if you're wearing earrings, it will detect that as well. So this is a combination of both, applications of both like computer vision and natural language processing. So your input is an image which is related to vision, and then the output is, a sentence which is related to, natural language processing. So this project is at the intersection of both of them. Yeah. Next one. Yeah. So okay. So these projects that we showed, they were more, related to the application side. While there are also, some people who work on some research related project as well. So your research related work, they are usually, sort of either incremental, or they can be, about a review paper, or something that you are coming up with something new. So while individually, like some of us are working on, some research work with, some professors or mentors outside. As a club as well, there is some of us who are working on a review paper with one of our alumni. So that's it's just this is just tell you, like, there is a mix of both research as well as, the applications. And also Abhilash, previous slide. Yeah. So this is we also have weekly paper discussions. So here what we do is we read papers, and since it is not only about the research, some of us are more interested, in how to code these algorithms out, or how we can implement whatever is suggested by the papers. So some of us end up, working on the implementation, and so we also, yeah, we discuss these weekly. Next. Yeah, so here's an image of some of our paper discussions. I mean, back in campus when, everything was offline. And next. Yeah, so this is the state in the online session, at least. So, luckily we are not affected much by it. We can, still go ahead with discussions on Google Meets and all of that. So one thing is that, it is very important for anyone who is working in the field of AI, even if you're working in the industry, just to stay updated with everything. You need to be able to, know what is the new state of art, or like, what is what are improvements in the research, just so you can make your product better. So being able to read papers is not only for those who are interested in working on the research aspect of it, but for people who would, who would want to work in the application aspect of it as well. So with our weekly readings, in the starting, like reading a research paper might be a bit intimidating, but because, we do it very often, like most of our members right now are familiar, how to read a paper and how to understand how these, research papers work and what they're trying to convey. So next. So we also do have hackathons, competitions, and lectures. So hackathons are, they can be like a 24-hour thing. Like, we will give, we will have a problem, and there will be like teams, and, some of us sit and work on these problems for 24 hours. And at the end of this, we will go through what everyone's worked on, and, there will be like a winner declared, or everyone will present their work. And yeah, so that's how hackathons work. And lectures are, where people who are especially, experienced in any of the subdomains, they share their knowledge with, the other people who are relatively new to these domains. So yeah, that's how it works. Next one. Yeah, so here you can see some pictures. Yeah, next one. Yeah, so this was at the Inter-IIT Tech Meet. So our team, with some of our members, we won a silver at the Inter-IIT Tech Meet in the data science event. Yeah, next one. So we also have webinars. Yeah, next one. Yeah, so these are some of the images, as I mentioned earlier, it is very important for us to, have a good relationship with the mentors of the club. So, luckily for us, they also give us some time, and they also, take time to talk to us about their experience, how they, worked on AI, the path that they took. And, I think often you might have heard, it is better to learn from the experience of others rather than, trying to make it out for yourself. So by this, we are also able to learn, like, how we can proceed further. So yeah. Next. So, what you can expect from us? So, as I said earlier, we are this community of people, that you can learn, collaborate, and discuss with. So, normally, when you're reading a paper or when you're learning a new concept, you might understand it in the first attempt on your own, but there is also a chance that you might not. And this is where it becomes important to discuss it with your peer group. And IITG.ai is a perfect environment for that. So even in our paper discussions, what happens is there's one person who presents the paper, and like some people might have doubts related to that paper. So if I have a doubt with respect to some part of it, someone else while reading that paper might have understood it. So they will volunteer, and they will help me clear my doubt. So that's how it works. So we try to work on things together, and try to learn together, and grow our knowledge together. And also, of course, you have a new project idea that you want to work on. You immediately have this community of people who are excited about AI, and who really are looking forward to work on something. You can immediately come pitch your idea to any of us, and you will immediately find like a lot of people willing to work on that. And also the other thing is mentorship. So this is very important, especially in this field. Like, so suppose I want to I'm someone who works on natural language processing, but I want to learn about vision. And usually, as I mentioned earlier, it is not common for people to be well versed in all these domains. But there is someone in this club, who is working on the vision aspect of it. So I can immediately, go up to them and be like, how do I start learning vision? Like, what courses should I do, or what blogs can I read, what papers can I read, or what is the state of the art that in vision that I'm supposed to be aware of. And so one set of mentors is from our peers, and you can share knowledge that they are with the domain that they are more proficient in amongst each other. The other is from your seniors, related to maybe interns, or related to projects. If you have any questions, you can ask your seniors. And if you really are more interested in your entire career path or something like that, you have our alumni and our mentors who will probably be more better to answer these questions. And of course, like you can work on projects as well, something application based or research based, or amalgamation of both, depending on your interest. And also you can develop your skills, both personal and technical. And I think technical it's obvious, because of course from the start we've been stressing that we are a community who learns, discusses, and collaborates and grows together. And personally, as I said, right, we have these weekly paper discussions. So you might be in charge of one of these paper discussions. So what will happen is that you will come up, and you will present this paper to the group. So you can make your slides, you can explain this paper to the whole group, like how what they're trying to accomplish in that paper. And by this, of course, your presentation skills improve, and you will start learning how to pitch an idea, or an existing idea, or your own idea to a group of people, which may be important, very important, like later on. Next. Yeah, so what we expect is that you are dedicated, and when I say dedicated, I mean that is it echoing? Abhilash, can you just mute? Yeah. Yeah. So when I say dedicated, Animesh, can you also mute? Sorry. Yeah. Okay. So when I said dedicated, what I mean is that if you come across something new, it would be great if you can share it with the group. Okay, like this is something that's really cool that I saw, and you guys can look at it as well. And if there is something that and something that someone else has a doubt in, it's as simple as that. Just help them out. So this is the main values that we work behind, is that you help each other, you learn from each other, and you grow from each other. So it shouldn't just be a give relationship, but a give and take, where you also contribute to the club, you also share what you have learned, or um, your experience and all of that. So this is just the most simple thing that we do expect. Next. Yeah, so now for the question how you can join. Um, yeah. Okay, sorry, Abhilash, yeah, you can show your model. Yeah.
Okay. So like, at the start, I showed you again the AI will try to learn how to play this game. I'll show the results of the after AI learning for teacher. Can you continue? Like, there is some problem.
Okay, cool. Yeah. Can you share the screen though, Abhilash?
Uh, there is problem with the screen sharing. Like, after at the end, I will continue with the.
Okay, I will share my screen then. Just give me a second. Yeah. So for the question, how to join. So what usually happens is, if things had turned out, normally we would have floated a course in December, but that's not what happened. So now what we will do is we will float a course, maybe during summer or a month before that. So the course is, it has like 9 weeks, 9 to 12 weeks of the course. So it is pretty intensive. So, we will float it in a time when you guys are relatively freer. So we will check that up and we will float a course. And once the course is done, you guys will have interviews, and then, you guys can join the team. So in the first year, usually what people do is, you try to learn about machine learning, deep learning, with at least the basic knowledge that is required. So when you do join the club, you can take part and understand the paper discussions, or at least reach the level where you can work on the projects. So since we are more inclined towards research and development, where both of them go hand in hand, it is very important for us to know how, like, the algorithms we are working on, what is the math behind them, or what is how they work, at least not just the math, but how they work, rather than just driving blindly into how you can code them out. So once you're aware of how they work, you will be able to do the coding part and the implementation part in no time. So what you will be doing is, through these courses, you will focus more on how you can learn all of these, and that we will float the course when you are also relatively free. We will post the information through Facebook, so you will be aware of that. So once these courses are done, you can take we'll have some interviews, and then ideally towards the mid of summer, or in your second year, you will be joining us. Next slide. Acha, I'm presenting, sorry. Yeah. So, however, if you're really interested and if you want to get a head start, you can, start going through these courses now on itself. So there are these two courses on Coursera. One is Machine Learning by Andrew and G. These are standard courses that anyone who is interested in the field of AI is expected to have done. So this is the first course. In fact, we will be floating these courses only. So if you want, you can just start right ahead, and you can apply for financial aid. There is this option here. You can just Google that up, apply for financial aid, and start working on these courses if you really want to start right away. And this course will probably take you a couple of weeks time, and once that is done, you can move on to the deep learning specialization. This is a bit more bigger, and will take much more time. But if this machine learning course is really interesting to you, and you can move on to this deep learning specialization, here as well you can apply for the financial aid. So yeah, let me go to the next slide. Yeah. So do you guys have any questions? You can just
Nietzsche, I will continue with
okay,
that.
okay, yeah, sure. Abhilash.
I Nietzsche, can you turn off your sharing? So this is the video that I showed earlier. That now in this video you can clearly see that computer is like doing at the start. It is taking some random actions to play this game. The AI, the white one is our AI model, which is trying to play this game. You can see that clearly the lights and the score was pretty low, and it is playing very slowly, and it is like the score was only 60. After 15 minutes of learning the game, our AI model is working like pretty fast. Yeah, you can see the score is like going up very fast, and the AI movement is also very fast. After a 70 or 80-minute training, you can see that it is like training, like it is playing very good. The high scores were in 800. This is the model I trained like parallelly with the presentation. In the span of 60-70 minutes, this model tried to learn how to play this game. Basically, yeah. Any questions?
So I think one person asked, what is financial aid in a free course? So the financial aid for you is to get a certificate saying that you have completed the course. And usually, once you apply for financial aid, you get the certificate for free. Otherwise, you might have to pay some amount. But with the aid, you can get the certificates for free. And also someone said, please let us know upcoming opportunities for us in the club. The main thing right now is we will be floating the course at one point, or you can, go through the uh, courses yourself. So right now, in the immediate future, there isn't much until you have completed the courses. So once you're done with the courses, you can be a part of the club. You can take part in the discussions, the projects, and all of that. So your time up until that would be working on these courses. Meanwhile, we might have some webinars or something, and if it is if it is suitable for you guys, if it's about some basic stuff, we will share that with you as well. And yeah, is certificate recommended? Yeah, it is usually it is usually recommended that you get the certificate, because there is no big process with the financial aid. It's just a small thing that you have to do. You just have to write like 2 essays, and then you get the certificate as well. So it is just a proof that you've done these courses. And usually the first thing people put up on LinkedIn is the Coursera certificate from doing machine learning Andrew NG ka course and the deep learning specialization. So yeah, you can it is always a good idea to get the certificate. Yeah. Any other questions? Cool. So how long are these courses? Okay, so the first course in Andrew NG, like if you see in Coursera, it says that you will have to. It is of 12 weeks or 9 to 12 weeks, if I'm not wrong. But it depends on you. You usually, at least like when I was doing the course, I didn't end up taking 11 to 12 weeks. Like you can do 1 week of content in maybe one day only. It depends on your interest and how fast you do want to go ahead with it. So in my year, at least what I did, I put the course on 2x speed, and I was able to complete like 1 week ka content in like one day. And it depends on you. You can do it in like 1 or 2 days at max. And depending on the time you have, you can pace it accordingly. But the deep learning specialization is a bit more longer. It consists of 5 courses. So it will take much more time. So yeah, no, you don't have to give your card number for the financial aid. So for the financial aid, you just have to type 2 essays. You can just Google about it, you will get an idea. So you do not have to give your card number. Um, okay, I think that's it for the questions right now. You have anything else, you can just put it on the chat. Maybe we will answer it through a post, or you can contact any of us for that matter. Yeah. So we will put up. Okay, someone is asking if there is any deadline to complete the courses once enrolled. No, there is no deadline. You can you can do it at your own pace. There is no deadline. Can those who already know some ML join the club earlier? So usually, if you do know some ML, we suggest you do the DL course as well. Um, you know, it would be better if you do the ML and DL course, and once you're very clear with all these fundamentals, you can join the club. What is the coding prerequisite for these courses? Okay, so the first course, Machine Learning by Andrew NG, it is done in Octave. So they will, they will explain it to you. This is a very simple language. So when you're doing the course, the basics will at least be explained to you. So if you're doing the course on Coursera, then there is no prerequisite. However, if you're doing the course that we will be floating the Andrew course, but with the Python assignments. So if you have like a basic knowledge of Python, that will be great. Otherwise, we will give you some links as well before the course starts when we are floating it, how you can get started with Python and all of that. So right now, what I would suggest for you to do is just be, thorough with your CS 101. I think you'll have like C or C++. Just be thorough with that. So once you know a language before, like it will be easy for you to, learn Python or any other language. In Andrew Ng's course, it had prerequisite of being able to write a non-typical program in Python. What do you recommend for us to learn Python? Okay, we will share some links with you maybe in the in the through Facebook in a post or something. But yeah, Abhilash. In our course as well, like how did we have the Python learning part?
There is some basic introduction to Python, NumPy, Matplotlib, and some tutorials from YouTube and internet blogs.
Yeah. I think coding blocks ka course, na?
Yeah, you can do that.
Yeah. So we will share these details with you maybe sometime. But the thing is, when we are floating our course, all of this will come together. So you can just go through that. Can you give us a rough estimate of when we should do these courses? So as I said before, ideally, it is a good idea to go through both these courses by the end of the summer. And towards, when I think you're in your second sem right now, when you're in your third sem, we would start uh, taking interviews. So by then, it is recommended that you finish at least Andrew Ng's machine learning course and maybe one or two to three courses from the deep learning specialization, if that's fine. We have to do these courses to get the knowledge to attempt the entrance test of the club or something. Yeah, so as I said earlier, we will have interviews. There won't be a test, but it is essential to have these basic ideas. So without this course, oh, okay, so you are in the first sem. Okay, sorry. Okay, yeah. So without these courses, you will not understand how these ML or DL algorithms work. And it would be futile for you to, come into these paper discussions, which you might not follow unless you have done the course or, are aware of the basics. So, when someone's asking, is it recommended to do it right now or can we do it later? It depends on the amount of time you guys have. At least from my knowledge of your sem, this sem is pretty packed for you guys. So that is why we were also planning on, floating the course during the summers when you might be a little bit freer as well. So if so, depending on your interest, I just put that slide in case anyone wants to get a head start. You can start with them. Otherwise, like it's fine. Like we will be floating a course, and you can just follow that pace. Okay. These are all the questions that I see right now. So I think we can stop at this point. But if you have any more questions that were not addressed, you can message any of us or Akshat or Varun or the second yearites, and we will be happy to help you as well. So yeah, one second. So can any branch people do it? Which is the best programming language for AI? So yeah, of course, like any branch, anyone from any branch can be a part of, the club. Your branch is not a restriction. And for the programming language, usually people use Python, but these days I think Julia is also a bit popular. But most of us work in Python only, so you can work on that. And yeah, I think these are all the questions I see right now. So, okay, guys, thank you. We will be ending this now. Thank you for joining us, and we look forward to seeing you in the club at one point at least in the future. So, good luck.